All right. So, this is the second programming workshop, and we're going to be talking about specific libraries and how they're used in the competition for the robot. So what are some of the uses of programming? So, as mentioned in the previous workshop, if you were there, to program we use libraries, and libraries are basically like sets of pre-made programs that we're able to use to help in our program and help develop more complex programming with less effort. And some of the things that we're going to be doing with libraries is computer vision, controls when you're aiming with the robot, autonomous movement, and driving with the controller during the actual competition. Like using all these libraries makes coding these actually not that hard. So even if you don't have that much experience, if you just learn how to code basic Java, you shouldn't have that much of a problem. So computer vision. What computer vision is it's basically there's a camera on the robot, and for every image it takes in, it analyzes each pixel and looks at the color. By looking at the color of each pixel, it's able to identify objects and like where it is, how far away it is, the angle it's at, and other stuff like that for it to be able to move and like pick up the object and stuff like that. In robotics, we use computer vision for many things, including the aiming systems, autonomous movement, driving, and just pretty much everything in regards to actually moving the robot and controlling it. And for those of you who don't completely understand, things like the face detection on your phone are kind of examples of this vision, computer vision. It basically takes in an image and analyzes each pixel, and by repeatedly doing that, it's able to identify various objects when you're looking at an image. So basically, if you put a picture of like a face, it'll be able to identify where the person is, how far away they are, what angle they're looking at, and other things like that. So for controlling and aiming, basically it's gonna take that image and look for the goal that you want to shoot into, like you can see in this video below. And by using computer vision, you're gonna have a lot higher accuracy and effectiveness when you're aiming with programming rather than by just aiming by hand. And this is a quick video just showing how the aiming works. As you can see, like by shooting it with the computer program, it's a lot more accurate. And you can also do things like applying a backspin on the ball, so that when it hits the back of the goal, instead of bouncing right back out, it bounces downward. Like as you can see in this video, the balls bounce straight downward because it's spinning backwards. And with that spin, it'll cause it to stay in the goal rather than bouncing out. And these things are a lot easier to do when you apply it with programming rather than just trying to do it with the controls that we set up. And these things will also be, this like aiming technique is also going to be very useful when it comes to autonomy, because when you're not controlling the robot, being able to aim accurately with computer vision helps a lot when it comes to the competition. So, and autonomy, and why we need autonomy, the main reason is at the beginning of the competition, there's the time period where you're not allowed to control your own robot, and the only thing you're allowed to move it with is like without any, you're not allowed to see the field, and you have to program the robot so that it's able to compete without you controlling it, basically. With autonomy, there's various things that go into making it, and one of the most important things is computer vision. Even though you're not able to see the field, the robot still can with its computer vision, and it's able to make decisions based on where the location of the objects are and where the goal is. And here's a quick video of a robot during the autonomous phase. So from the video, you're able to see that one of the robots was able to pick up a ball, shoot it into the goal, and then go back, pick up another one, and then shoot that one also into the goal. Compared to the other robots, that robot's autonomous was really good, and it gave the robot a big advantage in the competition. So if you're able to create a really good autonomous mode, you're gonna have a huge advantage when it comes to competition. But also, other things that help with autonomy is specifically conditions. For those of you who aren't familiar with programming, what a condition is basically saying, if the ball is over here, then you're gonna do something. It's like if a condition is true, then tell your robot to complete a certain action. Conditions are one of the most important things in programming, and it's one of the things you're gonna use the most. So basically, being able to analyze the situation, see what's happening, and then reacting to that situation is what helps a robot and a program work efficiently. And these conditions is basically the very basics of like computer, like artificial intelligence, and autonomous in general. Like you have to be able to analyze your situation and react based on the conditions that are presented. And driving. So driving is basically controlling the robot using a controller, and the components of making these controls includes computer vision, conditions, and various classes like Maxim mentioned yesterday. So as you can see in the image, one of the things that you have for is the what the robot can see. That's basically the camera presented on the robot, and it's basically showing you from the robot's perspective what it can see. And then also you have the controls. When you're controlling a robot, basically it can be anything from like an Xbox controller to like a joystick and stuff like that. By using computer programming, you're able to connect that controller to the robot. So whenever, for say, you push the joystick forward, then the robot will move forward. And coding stuff like that is very basic. Like it may seem hard when you think about what you're gonna have to do and like the result in the real world, but when you start coding and once you start learning programming, it's not that difficult at all. By using things like conditions in various classes, you're able to control the robot with very little work when it comes to programming. And when you refer to classes, when you're using a controller, there are these things that you called methods. And what a method is basically when an action occurs, you're gonna call a pre-made program to activate. So let's go with the example from yesterday. Say you have a drivetrain class, right? So what that class does is that it sends messages to the drivetrain and tells it how to act. So what you can do is you can connect that class to the controller, and whenever an action occurs on that controller, you can basically call the drivetrain class and say, "Hey, can you tell the drivetrain to do this?" And then it'll work. So by connecting various classes through calling, we're able to make a much more complex movement and have various conditions cause movement when they're fulfilled. And using this, basically, we're able to control the robot throughout the competition and make it drive smoothly if we have proper programming. And that's all we had to talk about. I know there's a lot of complex topics when it comes to programming, so if anyone has any questions, let us know. And if you don't want to ask any questions during the meeting because you don't want to like unmute, then you can always just message either me or Maxim after the presentation.
Yep. So yeah, we're all good. Make sure to sign your things. This is the last warning. Just make sure you get everything signed. It's all on Classroom. Um, and just submit it. That way we can add you to the team. Uh, yeah. Next week is gonna be, I think, finance. Wait, no, I think it's PR and possibly art. I think. Um, I'll check the thing later, but yeah. If anyone has any questions, just feel free to ask. All right, yeah. If you're good, if you don't have any questions, then we're all good. Guess we'll see everyone Monday.